Streaming is an incredibly important UX consideration for building LLM apps in a few ways. First of all, even if you're just working with a single LLM call, it can often take a while, and you might want to stream individual tokens to the users so they can see what's happening as the LLM responds. Second of all, a lot of the things that we build in LangChain are more complicated chains or agents, and so being able to stream the intermediate steps, what tools are being called, what the input to those tools are, what the output to those tools are, streaming those things is really important for a nice UX as well. So we've recently added a new method in LangChain to help with this called stream events, which hooks into the callback handlers we have, so it's very easily modifiable. And what it will do is it makes it easy to stream everything, basically. And so this video will cover stream events. It will also cover the basic stream and async methods that we have. So these are simpler methods for dealing with the end responses of chains or of models. And it will take a look at doing this for generic runnables and then for LangChain agents as well. So let's jump into it. This is the docs right here. Little known fact, all of these docs are also notebooks, so I'm going to open up the notebooks version of this. Let's restart my kernel just so I can do it with a clean env. And yeah, we're going to cover two main things here. We're going to cover the stream and then async methods. And these are methods for streaming the final outputs of chains. And then we're going to cover the stream events method. We're going to cover the stream events method, and this is a way to stream all the events that happen within a chain. So all runnable objects in LangChain, and so these are all chains, these are all models, these are basically all objects in LangChain expose a sync method called stream and an async variant called astream. And so these methods will stream the final output in chunks, yielding each chunk as soon as it's available. And so as we see as we'll go along, streaming is only available if every step in the program kind of like knows how to stream things along. So if you're working with one step in the program, like an LLM, if it knows how to stream, then you can use stream. If you're working with multiple and maybe one of them doesn't know how to stream, and we'll see an example of this later on, then it might not stream. So let's start by looking at the LLMs themselves. So we'll use an Anthropic model here. And basically what we'll do is we'll iterate over the chunks in model.astream. The things that come out of these are going to be AI messages. And so what we're going to do is we're going to append them to a list, and then we're going to print chunk.content. And so this is just a content field on the AI message. When we're going to print this little operator to show the spaces between the streams. So we can see that it starts to stream as it responds. If we look at one of these chunks, we can see as it's AI message. These AI messages we've made kind of like addable under the hood, so you can add them up and you can get the final response. Okay, so that's a simple LLM. Now we're going to look at chains. And so in this chain, and so chain is kind of like anything constructed in LangChain expression language. This chain will just be a really simple one where we have a prompt, a parser, and then the chain is prompt model parser. We will invoke it with astream, so we'll use async here, and we'll stream over things, and we can see what happens as it goes through. And so basically we're asking, we have a prompt that's formatting it with it's tell me a joke about blah. We have this model, and then we have this parser, and this parser is just responsible for taking the content property off of the message, and so it'll just return a string instead of this AI message. The model and the parser expose stream methods, so we'll see that it will stream out as it completes. There we go. All right, so we can also see an example of other things. A more complicated parser that we have is the JSON output parser, which takes in a response from a language model that is supposed to be JSON, but it might be like half completed JSON, right? So this happens when you're streaming. Like when you're halfway through the stream of a JSON blob, it's not valid JSON, and so this parser deals with a lot of those peculiarities and parses it accordingly. And so we can see here that it will start to stream out the more completed kind of like JSON blob as we create it. Here we'll see an example where this doesn't stream. So this is a method that just returns all of the country names. And so here, if we add this on the end of the blob, we can see that there's actually no streaming that will happen because this final thing, it doesn't yield things. It doesn't stream. It doesn't take in a generator, and it doesn't return a generator. And so it kind of blocks everything. So it just returns it once at the end. If we want to change that, we can change this, and this will start to yield things. And so why is this happening? I think this is happening because I have some flush issues here. Let's do this, see if this changes things. Yeah, so we can see here once I add in this, so there's some flush issues going on, but basically we can see that it streams back tokens, and again, that's because this yields things. Some built-in components like retrievers, these don't stream anything. So if I call this, it just returns a list of documents. We haven't really seen a need for retrievers to be streaming, so that's why we kind of haven't implemented a version of that. But you can still use these within chains. You can still use retrievers within chains and still stream the final results. So here's like a really simple RAG chain that gets the context back. So basically calls a retriever, gets some documents, passes it to a prompt, passes it to a model, passes it to an output parser. These still stream, so we'll see that the final response we can stream. All right, so those are covering kind of like the basics of stream and astream. The big kind of like limitation of these is that it only streams the final kind of like output of a chain. Oftentimes we might want to stream the intermediate steps or the events that happen within the chain along the way. So we'll walk through this new method, stream events, and the events that it produces are aligned with the callback handlers that we have. And so we have a bunch of different types here that we've listed here. So we kind of like have, so this is for chat models and LLMs, very similar. We yield something on the start, we yield something on the end, and then on stream we also yield each token if the model supports streaming. Same for LLMs, same for chains, same for tools, same for retrievers, and then same for prompts. Prompts just has start and end. One thing to note is that this is a beta API, and would love to hear any feedback about it, so please let us know. So here we can start. We can use we can just use the model, and we can call a simple model, and we can take a look at the stream events that are associated with this model. One thing that you may notice is this version thing in astream events. So what is this? Basically, we're documenting kind of like the API for this astream events interface. As mentioned, it's a beta interface. It may change, so we want to make it easier to do that in the future. Let's take a look at what some of these events are. So we can see that the first one is on chat model start. So it starts kind of like the streaming, the first event, it hits the chat model start, and then it's chat model stream, chat model stream. So basically what's happening is the input's going in, it's starting the chat model, and then after that, it's getting token by token. If we look at the last results, we can see that it's on chat model stream and then on chat model end. So this is a very simple single call to a chat model that first calls the event on chat model start, then calls stream on each token, and then calls on chat model end at the end. Let's take a look at the chain that we have. So now we have this model and we have this JSON output parser. Let's gather the list of events and we can explore them this way. So the first three events that we see are actually all on blank start. So first we have on chain start because we entered the overall chain here. Then we have on chat model start because that's the first one. But then the model streams things through, so it passes a generator through, it passes that generator through right away to the output parser, and so we immediately hit kind of like on parser start. We can explore this a little bit more by looking at some different events. So let's look at maybe like the last three events. In here we can see that we have on chat model end, on parser end, and then on chain end. So this makes sense. It's if we imagine kind of like the sequence of chain encapsulating a model and then a parser, basically the model will kind of like finish, then the parser will finish, and then the chain will finish. Let's look at maybe some of the middle ones. So if we look at like 3 to 6, we can see that what happens. Maybe let's do 3 to 7 for just a slightly nicer thing. We can see that it's a mingling of on chat model stream, on parser stream, on chat model stream, on chat model stream, on parser stream, on chain stream. So what's happening is as the chunks occur, because we stream them all the way through, we first see one token come out of the chat model that gets passed through to the parser, that gets passed through to the end of the chain. And so it's this sequence of events. So now we can take a look at using these real time to do some streaming. So we will do this by parsing the events that get emitted by this stream event. So first we'll take a look at each event, and we'll take a look at what the kind of the event is. Then we can basically do things depending on what the kind is, and we'll just do some simple string matching based on the name. So if it's on chat model stream, this is when it's printing out a token. We'll print this chat model chunk, and then if it's on parser stream, this is when it's going through the output parser. We will pass that, and we'll set flush equals true. This will get rid of some of the flushing issues that I had above, and yeah, we'll just only do this for the first 30. So we can see now that we start printing things out, and it's intermingled with chat model and parser, because basically the chat model starts accumulating tokens, and at some point then the parser emits something, but they start streaming kind of like at the same time. There might often be a lot of different events coming out from your chains when you have complicated ones with more types of models, different types of tools, subchains, things like that. And so we want to make it really easy to basically filter these events. We have a few ways of doing that. One is by name. So you can assign any runnable. So again, a runnable is just a model or a prompt or a chain or an output parser. You can assign it with a run name, and then you can filter the events by include names. So here we give the model, the run name model, the output parser, the run name my parser. We have include names only my parser, and then if we print out events, we will only get events related to the output parser because we're filtering out the ones with the run name model. If we switch it up, we go model, then we only get ones associated with the model. Another way to filter is by type. So we have the same chain here, but we're just going to change include types. And so now include types we're going to set next to chat model. This will get all chat models. So if you want to get all chat models regardless of the name that you give them, you can get them this way. Tags are another way to do it. Tags are basically inherited from any child component. So here we're going to give this whole chain the tags my chain, and then we're going to stream all events and include tags my chain. My chain, so the way that tags work, it's not just events associated with this chain, it's with any sub child components as well. So if we stream it out, we see that we start to get everything. We get chain, we get on chain start, on chat model start, on parser start. In this case, because we tagged the whole chain with my chain, this is everything. If we take a look at non-streaming components again, we can see that, so this is the one that blocks the final result, doesn't stream. If we look at a stream again, this is the same example as above, it doesn't stream, but if we do stream events, it does, and because they get passed through up until that point, so we can see kind of like everything going on. Another thing, this is a slightly more advanced one, is basically if you have basically custom tools and they have inside them a runnable, then what you want to do is you want to propagate the callback so that otherwise no stream events will be generated. A common example of this is if you have a tool for an agent and that tool calls an LLM, you need to make sure to propagate the callbacks correctly. So here is an example of it not propagating correctly. And so you can see that there's basically just the stuff for tools, because even though it calls this runnable inside of the tool, the callbacks aren't propagated, so it doesn't actually know that exists. If we now propagate them, and you can do that by just adding in callbacks as an argument to this tool function, and then passing it in through callbacks here, you can see now that we get this on-chain start and on-chain end event, and these occur in the middle. And so these are, I think, more examples of just the same. All right, so that covers basic streaming stuff. We get most of the questions around streaming around agents. And so I want to show 2 examples of doing that. So this is the streaming page in the LangChain documentation that shows how to stream with the agent executor. So let's restart the kernel so we can see what's going on here. If you don't know what agents are, check them out in a separate video. I'll link to one in the description. Basically, with agents, the first thing we're going to do is we're going to define a model, and we're going to make sure that streaming set equal to true. This is necessary so that it streams no matter where it's called from. So in an agent, it will be called within the agent many times. So we set streaming equals to true, and then we define our tools. And so these are just 2 example tools. We can play around with them, and then we initialize the agent. And so here we can see that we are going to first pull a prompt, and we're going to use this prompt for our agent. We're then going to list out the tools. We're then going to create the OpenAI tools agent, and we're going to give the model here a tag, agent LLM. And then we're going to create the agent executor. This is the runtime for the agent, and we're going to give it run name agent. This covers streaming. So this is the streaming of the agent. The streaming of the agent does the individual steps. So that's nice, but oftentimes we want to get the individual tokens as well. So let's go down to custom streaming with events. So here we can do the same thing that we had before. So we have the input, we'll use version 1, we're using AStream events, and now we can start doing stuff with the events that are emitted. So if on-chain start, and if the event name was agent, so this is if you remember back up here, we tagged the agent executor with the run name agent. So this is basically saying whenever on the start and end of this, we are going to print out this, and then same thing on the end of this, we're going to print out this. And this is needed because there's a lot of subchains within this agent. There's places where we kind of like do the prompt into the model. Those are subchains. We really care about this overall agent. And then we care about the streaming of the tokens from the chat model. So we are going to basically, if it's on chat model stream, and if the content exists, and so there's actually cases where the content doesn't exist, and this is when tools may be called. We can play around with this and see what that looks like after, but for now, only if there's content, we're going to stream that, and then we'll also stream the tool start and tool end. So if we do this, we can see that it starts printing things out. You can see that it really quickly streamed that. And then it gets that. So if we take a closer look, we can see that it prints out starting agent. We then get a bunch of information about the tool, tool 1, tool 2, and then it starts streaming the final response. We can also change this so that it always prints out the content. And so now what we'll see, so we'll see here, so these things are when it actually, so this is when the content didn't exist. We can maybe even just print out what exactly it was. Yeah, here we can see that it prints out the whole chunk, and so we can see that the tool calls, and it's still streaming kind of like stuff, which is why it looks incomplete. But basically, this is printing out the individual chunks, which have the chunks of the tool call in it. So there's no content, but there's the chunks of the tool call, and that's what we're printing out here. That covers streaming with Agent Executor. There's one more thing I want to go over, which is streaming with LangGraph. LangGraph is a package that we introduced that makes it really easy to create agent runtimes as graphs and or state machines, essentially the same thing. And so because LangGraph is built on top of LangChain and is runnable at the end of the day, it has this exact same interface. So if we go over to LangGraph, we can see an example of this. Let's also restart the kernel here. We can create our tools. We can create our tool executor, which just runs tools. We can create the model. Again, we set streaming equals to true for chat OpenAI. We bind the functions to the model so it knows which tool it has available. We're now creating the nodes in LangGraphs. If you aren't familiar with this, I'll also link to a video for LangGraphs, so you should check that out. We just did a whole series of them on YouTube. We define a bunch of our nodes here. Again, we'll cover this in a video separately, or it's already been covered in a separate video. We define our graph here. And then this app that we get back, this is a runnable, like any other thing that's constructed with LangChain expression language. So we can start taking a look at it and using it in the same way. So we'll use AStream events. We'll look at the type of the event, if it's a chat model stream. So if it is a token, basically, we'll do the same thing where we print it out if it's not empty. And then we also print out the on-tool start and the on-tool end. So we'll run this with the inputs, what is the weather in SF. We can see that we get back, or it's logged, the starting input for the tool. We get the output, and then it starts streaming back the response of the tokens there. That's basically all I wanted to cover in this video. Streaming is super important to LLM applications, and so hopefully this new stream event method will make it really easy to stream back what is going on inside your applications to the end user. Again, this is in beta, so please let us know if you have any feedback or questions. Thank you.